Good morning. We're going to go over the polynomial long division. I'm going to do it one more time and show you a problem. And we're going to work it both with long division and with another way called synthetic division. And so often we will have a problem and it may be set up as this, like you've got your long polynomial. They have given you maybe a solution of 2 is one of the solutions. So if we know that 2 is a solution, x equals 2. When we find our factor, we are setting that equal to 0. So x minus 2, we would move our 2 over, would be equal to 0. So we know that x minus 2 is one of the factors of our long polynomial here. And so we can solve and find the other factors by using division. So in class, we learned about polynomial long division. So I'm going to reset up my equation where I'm going to put my long equation underneath the long division sign, and we're dividing it by x minus 2. Now, as we set up our equation, we need to remember to make our columns for each of the categories of our terms. So we're going to start with the term with the highest exponent. So we've got x cubed. Then we would need an x squared term, an x term, and a constant to work our way down. Well, in this case, this polynomial has an x cubed. It does not have an x squared, so we're going to put a 0 in that space. It does have an x term, and it does have a constant. So now we're set and ready to go. Remember, the goal is to get rid of your very first term that you're working with. So I want to get rid of x cubed. So how do I make an x into x cubed so that I can get rid of it? Well, we know that x times x squared gives me x cubed. Because I'm using x squared, it needs to go in the x squared column. X squared times x gives us x cubed. X squared times negative 2 gives us negative 2x squared. Now, because long division requires us to subtract everything on the bottom, that subtraction sign has to be distributed to both of these terms. And we know that subtraction signs change the sign that's already there. So we have a little saying, when we draw the line, we change the signs. And that will cause that subtraction to be distributed among both. So x cubed minus x cubed gives us a 0. We did exactly what we wanted to. 0 plus 2x squared just gives us 2x squared. Now, long division terms say that we drop the next one. So again, our goal, get rid of the very first term. How can I make an x into 2x squared? Well, 2 times x, 2x times x would give us 2x squared. So I'm going to 2x times x gives me 2x squared. Now 2x times negative 2 is negative 4x. We draw our line, we change our signs. Now we can work our problem down. 2x squared minus 2x squared is 0. We did what we wanted to, we got rid of it. Negative 5x plus 4x is a negative x. And I'm going to drop my next one down. Again, my goal is to get rid of x. I've got a negative x. And I have an x up here, so I need a negative 1. Negative 1 times x is negative x. Negative 1 times negative 2, remember the sign attaches to the number, gives me a positive 2. Okay, draw my line, change my signs. Negative x plus x gives me 0. 2 minus 2 also gives me 0. So we have a fully factored polynomial. We know that x minus 2 is a factor of our x cubed minus 5x plus 2, and the other equation is now x squared plus 2x minus 1. And now that this is a quadratic, we can use one of our quadratic steps to solve this. In this case, there's no terms of 1 that can get us 2 that are subtracted, and so we would use the quadratic formula or completing the square to find our other 2 answers. Now, we're going to work this same problem using something called synthetic division. Synthetic division takes all the constants and the coefficients that we have, and we work with that, and we're going to put it back in. So just like with long division, we have our equation set up. It needs to have terms in descending order. So we need an x cubed, if that's what we start with, x squared, x, and a constant in that way. Because we don't have an x squared, we're going to put a 0 in there. So we really have a 0x squared. Okay. So in this way, we are using the same setup as regular division, but we're only going to be working with the number part of it, knowing that each time our goal is to fully get rid of the x. This is what allows us to just work with the number portion of it. So in this case, if I had my division part here, so I have my x minus 2, my number portion is the 2. So here we have x minus 2, my number is a 2. Okay, and I know you're thinking, oh, well, there's a negative. At this point, it doesn't matter that there's a negative in that point. Okay, so we're going to put a 2 here, and that's what we're going to be looking at. Now we're going to take the coefficients of each part of our long polynomial that we want to divide, and we're going to drop them down. So the coefficient of x cubed is really 1, so we're going to put a 1. We have a 0 for that second term. We have a -5. And then we have a 2, okay? So we've moved our coefficients down. Now in this way, we are simply going to be multiplying and adding, okay? So the first number drops down, and then we're going to multiply and then add. So 2 times 1 gives us 2. Now we're going to add these together. 0 plus 2 is 2. So we're dropping down again. Now again, as we go around this bend, we're multiplying. 2 times 2 gives us 4. We're going to add as we go down. -5 plus 4 gives us -1. 2 times -1 gives us -2. We're going to add as we go down. 2 minus 2 gives us 0. When we get a 0 at the end, it means that it is fully factorable. Just as up here, we got a 0 at this end, okay? Now, these are new coefficients. So I have 1, 2, and -1. Remember, because we started with an x cubed term, our answer follows in the column that's straight down from that. So we're going to go in a term down for a coefficient. So because my original problem was x cubed, my answer starts as an x squared, x, and then my coefficient. So we have x squared plus 2x minus 1. And we happened to get the exact same answer, which is exactly what we wanted to do. So both ways, either usually using the polynomial long division or the synthetic division, gave us the exact same answer. So this is, you can use one or the other to check your answers on both, but that's the way that synthetic and polynomial division work together.